on the plateau. I am going to be going into detail about a collaborative project that took place between the Taos Archaeological Society and the Bureau of Land Management, Taos Field Office, to begin some preliminary documentation of a lithic procurement site known as Newman Dome, just west of the gorge on the Taos Plateau. And so as you will see in this presentation, Newman Dome for thousands of years has been a destination for foraging groups, kind of looking to gear up on raw material for making stone tools. And thanks to this partnership between TAS, the BLM, and the academic community, volunteers with TAS really contributed to our understanding of this site, through hands-on field work. And I'm hoping that, documentation of this site can continue in the future. So just in terms of how the presentation will go, I kind of want to just begin with a little bit about how the project got started, some of the folks involved, and how the site was brought to the attention of the Taos Archaeological Society and then the BLM. Then I will briefly discuss with you some of the previous work that has been done in terms of archaeological survey and excavation, and just some of the types of sites that are typically found out there on the plateau. And then, of course, what all of this survey and excavation data can tell us about Indigenous use of the area over the last 10,000 years or so. And in many ways, Indigenous use of the area is directly linked to the area's unique geology, and particularly the volcanoes or cerros. And so I'm going to dive into the geology of the plateau, but specifically about Newman Dome and why it was targeted for toolstone. And so this project, was important for both TAS and the BLM. And so I do want to talk a little bit about how the project relates to TAS's mission, as well as BLM goals and objectives for participating in these kinds of collaborations. And then, of course, the fun stuff. I'll be showing you guys lots of pictures and discussing some of the artifacts that we found and some of the things that the volunteers learned. And then lastly, I'll share with you some ideas for future research and the kind of work that we hope to accomplish next season and in the years to come. Okay, so here we have the mastermind behind this project. This is TAS member Bob Blair. And, this site was originally brought to the attention of the Taos Archaeological Society by Bob. And he is the one who initiated things with the BLM. So I think that he really kind of deserves the credit here for making this project happen. So Bob came across this site, because he was just out adventuring in the area one day, and he happened to notice that the surface was literally covered in debitage, which is just a fancy way of saying trash, but it refers to the flakes or the chippings that are the byproducts of making stone tools. So Bob continued to walk around and, he started to notice an abundance of bifacially worked tools like these dart points here, and also some other items of interest like this thing on the left. And so I think at this point, Bob realized that he had stumbled upon something fairly significant. And then so he started to open up discussion with the TAS Fieldwork Committee, about what, if anything, TAS should do about this site. So eventually Bob reached out to Natalie Sanford, who was an archaeologist with the BLM at the time. And she was really enthusiastic about working with TAS. And, if she hadn't have been there, I really don't think that this project would have taken off like it did. So I, for one, am very grateful that she was there. But after several back and forths, it was agreed that this would be an excellent opportunity for TAS to partner with the BLM to do some proactive site recording for the benefit of TAS members, but also for the chance for BLM to fulfill some of their obligations that they have with partner organizations. So initially, there was a lot of discussion between members of the Fieldwork Committee about whether this site had been previously recorded or if, the area had even been surveyed. And so I just want to take a minute here to briefly discuss with you guys some of the work that has been done on the plateau and particularly within the Rio Grande del Norte National Monument, which is outlined here in yellow. And this is because this just not only gives us kind of an understanding, some background information for how we know what we know about land use in the area, but it also kind of highlights why some of these collaborative and proactive projects are important. So if we just focus on the survey here in the monument, which is in blue, it's apparent that not a whole lot of survey has done. And in fact, less than 12% of the monument has been systematically surveyed for cultural resources. And so when I say systematically surveyed, for some of those of you who might not know, is just the process of kind of transecting or walking across the landscape, often in a linear fashion, spaced at specific intervals. And so in the state of New Mexico, this is about 15 meters or roughly 50 feet apart. So, but as you can see, most of the survey has focused around the volcanoes, kind of in the center there. And this work has primarily been done for compliance projects that have been related to vegetation treatments or recreation or transportation. And as it turns out, the Newman Dome site was actually previously recorded, but it wasn't fully recorded and its boundaries were actually incomplete. And so unfortunately, a lot of times when the for compliance projects, sites often don't get the attention that they deserve because their site boundaries, may continue outside of a proposed project area. And so they don't get recorded in their entirety. So the Newman Dome site spans this huge area, and it has clearly been visited by people for thousands of years. And so there's definitely a lot more work that needs to be done out there than what was originally documented. So having TAS partner with BLM just provided this really great opportunity to kind of go back and begin this long-term project that focused on documenting the site more thoroughly without having to be constrained and concerned with some of those constraints that land management agencies and contract firms often face. So as we just discussed, not a whole lot of survey has been done. And in terms of excavation, even less work has been done. But even with this limited data, we are able to glean some aspects of Indigenous use of the area. And so at the very least, we know that people have been in the region since the Paleo-Indian period. So that's roughly around 10,000 to 12,000 years ago, up until the present day. And then it would seem that across time, for the most part, the cerros or volcanoes play an important role in land use. So the vast majority of archaeological sites on the plateau kind of just consist of these ephemeral superficial artifact scatters that predominantly include lithic artifacts like debitage or stone tools. But occasionally we do have some ceramics. We've also got rock features like cairns or hunting blinds. And then of course we have some of the more recent items from the historic period. But what we can gather from these sites is that the plateau has really just provided, abundant, diverse, and variable resources for people moving across the landscape, but that those resource targets possibly changed throughout time. So, for example, the environment on the plateau 10,000 years ago would have been very different than it is today. It was likely a lot wetter, there were less trees. So hunting and foraging strategies during the Paleo-Indian period were probably focused more on the exploitation of streams and playas within some of the more plains-like settings that you see on the plateau, like in this picture here. Paleo-Indian sites are actually, they're exceptionally rare on the plateau, but folks have found some artifacts that date to this period. So we do know that people were out there doing things. Later groups, especially during the archaic period, which follows the Paleo-Indian period in time and dates to around 8,000 to 1,500 years ago, focused on exploiting a wider range of resources within some of the woodland settings. And so this was likely in response to a changing climate. So this is kind of when things started to become a little bit more like they are today. We see the expanse of the pinon juniper woodlands, and things just kind of start to become a little bit drier. And so interestingly, it is during this time that we also start to see a profound increase in the use of non-obsidian volcanics for the manufacture of stone tools. And we start to see this glassy basalt start to become, it becomes extremely common at archaeological sites across the plateau. However, what has commonly been referred to as glassy basalt is not actually basalt at all. It's often referred to as basalt primarily due to its dark gray or black color, which is indeed similar to basalt. But what we are seeing at archaeological sites is most likely andesite or dacite. And in the case of Newman Dome, however, we do know that it is actually dacite because its geochemical composition has been analyzed. And so in saying that term, geochemical composition, I just wanted to pause and give you a heads up here that I am in a little bit going to go deep into some geology stuff, and that at some point you might be wondering, why the hell am I going into all of this stuff? But I promise that it will all make sense when I'm done. Okay, so here we go. What is dacite? In many ways, dacite is very similar to basalt, in that it's a dark colored volcanic rock, and it has a similar origin story. But this material is in fact different from basalt in that it has a higher silica content. And so silica is a naturally occurring mineral that is found in many rocks, but when it occurs in high enough contents within particular rocks, that is what makes certain stones knappable. So if you think of things like flint or quartzite or obsidian, all of those stones contain a large amount of silica. So basalt geochemically actually does not have enough silica to be knapped in a predictable way. So in essence, what we're looking at is the difference. What really differentiates basalt from dacite is silica content. And so these pictures here are of some large dacite boulder outcrops that occur in parts of Newman Dome. And you can see, especially in the one on the right, how it does have this glassy appearance. These ones in particular are from an area of the site that Bob has named Shackley Gulch, which you'll understand a little bit why later in the presentation. But so how does dacite form? The Taos Plateau, or the Taos Plateau volcanic field, as it is formally known, is actually very special geologically. It's got over 35 shield and dome volcanoes, and it covers an area of over 7,000 square kilometers. And so this makes it actually the largest volcanic field in the Rio Grande Rift. And so most of these eruptive events on the plateau occurred between 5 and 2 million years ago, and they're compositionally variable, but the plateau floor consists predominantly of basalt and andesite flows, which is this large swath of green that you see here in the figure on the left. And those formed around 4 million years ago. And so these are actually the flows that you see that have formed the layers that you see when you look into the gorge, for example. The volcanic domes and shield volcanoes on the plateau are of various ages, some of which you're probably familiar with. We've got Ute Mountain, San Antonio Mountain, Cerro Montoso, and these are compositionally different from the basalt flows that make up the valley floor. And these are shown here in pink. And so there are many reasons that these could be compositionally different, but it primarily has to do with the minerals that are present in the magma. And so in the case of these volcanoes, they contain more silica than what is occurring in the surrounding basalt. And so this characterizes them more as andesites and rhyodacites. And of these, there are only a handful that actually contain artifact quality material, and Newman Dome is one of those. Okay, so here we have Newman Dome in all of its glory. As you can see, it is a very subtle feature on the landscape. And while it does kind of form this dome-like shape, it isn't a dome in the same sense that like Ute Mountain and San Antonio are domes. It has to do with the way that it was formed. So Newman Dome formed because of a fissure that was created just north of the feature after the emplacement of Cerro Montoso, which is adjacent. And so what happened was as magma oozed through these fissures or vents, because it is dacite in composition, it has kind of like a thick viscous lava. And so over time, as it flowed out of those vents, a dome-like feature was formed. Newman Dome actually has an interesting orientation as well. And as you can see, isn't this nice round dome, but rather kind of trends linearly north to south. And this is because as that high silica lava flowed away from that main vent, the one that you see to the north there, it was constrained by the local topography. So you have Cerro Montoso on the west and the gorge on the east. And so as we will learn, this unique geology of Newman Dome is one of the reasons that people were drawn to this place. And this, site that Bob just kind of stumbled on may come to have some really important implications for archaeology. So at this point, some of you may be wondering why you have never heard of Newman Dome. And this is because for a long time, it hasn't actually had a name, unless of course you consider being called unnamed a name. Geologists have referred to it as the unnamed Cerro east of Montoso. And I have also seen it in the archaeological literature as Cerro sin nombre, which means the hill without a name. And so it is really interesting to me, that nobody has named this feature, especially since geologists tend to name everything. But in the 1980s, a couple of researchers, Jay Newman and Roger Nielsen, were investigating possible stone tool raw material sources on the plateau, including this dome, and they used X-ray fluorescence. But despite even recognizing it as a source, they didn't give it a name either. And then in 2010, geologist Steve Shackley, who is primarily known for his work with obsidian, revisited the dome to just further investigate its archaeological use. And in 2011, he published this article, Sources of Archaeology in New Mexico, in which he refers to the source as Newman Dome, in recognition of archaeologist Jay Newman being among the first to discuss the feature within an archaeological context. And so I think that most archaeologists who are familiar with this article just have also adopted the name and refer to it as such. Okay, so I just mentioned that Jay Newman and Roger Nielsen were the ones to first use X-ray fluorescence, or XRF, to look at raw material sources on the plateau. So archaeologists for a long time had been curious about what this ubiquitous black rock is, where it's coming from and what its distribution is. So, okay, well, XRF provides one way of answering all of those questions. And so XRF, if you're not familiar, is basically the process by which rock samples are irradiated with high energy X-rays to determine their elemental composition. And so what's happening is as these rocks are being zapped by these X-rays, the minor, major, and trace elements within geologic materials can be identified based on the way they behave once they've been irradiated. So to identify volcanic materials, what we're looking at is the ratio of high alkali elements to silica elements, and these would be considered the minor and major elements. So as you can see in this figure here, which is from the Shackley article I just mentioned, you can see on the bottom how basalt is different from dacite and even andesite because of the amount that silica that's present relative to other minerals. So what's fascinating about the trace elements present within volcanic rocks is that they occur in different amounts at different sources, and this kind of gives each source its own sort of fingerprint. And so what this figure is showing here in terms of the dacite sources that were analyzed by Shackley in that 2011 article, so these samples just kind of show up on these plots as clusters based on their elemental composition. And so this is actually how we know, for example, of all of the different obsidian sources and what their distribution is across the country. And so in that same way, Shackley used XRF to, on samples from the plateau to discriminate between dacite sources. And so I do just want to clarify here that San Antonio Mountain and Newman Dome were analyzed by Steve, as was the Cerro del Rio source, which is by Bandelier. But that does not mean that they are the only sources that were targeted for toolstone. Locally, we also have the Guadalupe Mountains and Cerro Negro, for example. And so those have also been recognized as being important sources of toolstone. And it's just the case that a lot of these other sources haven't been researched to any great extent. Okay, so that concludes your upper level geology crash course. And we can now bring it all back to the people, which of course is what we are interested in as anthropologists. So for obvious reasons, XRF is useful for archaeologists. For one, it provides us with a way of classifying and sourcing lithic raw materials, particularly obsidian. But as Shackley has demonstrated, it's also useful for sourcing non-obsidian volcanics. But we can also use XRF to even source ceramics. And again, because each source location has a unique geochemical signature, once those materials are analyzed and provenanced, we can identify archaeological materials that are coming from there. And so this, of course, is of interest to archaeologists, because if we know where raw materials are coming from, we can begin to address questions, related to land use and mobility, trade and exchange, and how resource use may have changed over time. So for example, this diagram here from a study that used XRF shows relationships between folks living in the Mesa Verde region and obsidian sources in Northwest New Mexico and Northeast Arizona, which are the little black circles. So researchers in this article used that geochemical fingerprint from obsidian artifacts that were found at Mesa Verde to identify the source of those artifacts. So then they used that information to identify shifts in trade, migration, and cross-cultural interaction. And as a result, we're able to infer changes in the relationship between the people of Mesa Verde and the surrounding regions during a pretty significant period of time, which was this collapse that kind of took place around the 1200s. So all of this is incredibly fascinating. And, and I think that with more research like Shackley did with the Newman Dome source, on other sources across the plateau and even the Southwest, we'll really start to gain a better understanding of the significant materials over space and time. So why are we interested in this material? This material actually, dominates most assemblages at archaeological sites on the plateau, if not most of northern New Mexico. But it's especially ubiquitous at sites that date to the archaic period. And so why did these past forager groups find this stuff so appealing? Interestingly, despite their presence on the plateau, the Paleo-Indian folks, especially from the earlier Paleo-Indian period, seem to have just kind of passed over this resource entirely. And Paleo-Indian points made from dacite are extremely uncommon, though they're not entirely unheard of, but they're definitely not as common as points later in time. And so one of the reasons, the dacite at Newman Dome was so appealing to archaic forager groups could have to do with the size and shape of the nodules, which you can see here. So these would be conducive to creating large bifaces from which dart points can be made. And archaic style points do tend to be large to medium-sized dart points. Also, recall how I mentioned earlier that it was during the archaic that we start to see a greater exploitation of resources within woodland settings. Well, some researchers have suggested that dacite is more durable than other materials and is thus more conducive to hunting within woodland settings where you may have an increased chance of missing your target. So, if you're using dacite, your point won't break as easily in the event that you hit a tree or hit the ground. But this material does also turn up in assemblages that postdate the archaic period as well, especially at local sites. And so Newman Dome is actually the predominant material type in the Pot Creek Pueblo assemblage. And so for some of these sedentary groups like this in the region, this source was appealing, maybe not so much because of nodule size and durability, but because it provided an excellent source of raw material without having to travel great distances to obtain. Newman Dome dacite was also targeted as a tool stone because it is such a quality material compared to other dacites and other non-obsidian volcanics. And so Shackley, for example, says that of the 3 major dacite sources detected in early sites in New Mexico and Colorado, the Newman Dome dacite is the finest raw material of the 3, and that its knapping quality is similar to some chert materials, less brittle than obsidian, but certainly more brittle than other volcanic rocks. And so given Newman's Dome unique geology, and location relative to other sources. We can basically think of it as a one-stop shop for past forager groups. You have, it's basically, you've got your hardware store right next to your grocery store. So what more could you ask for, right? Okay, so I'm going to shift gears here a little bit and start talking a little bit more about the project itself. In terms of tasks, this project really afforded a great opportunity to fulfill TASS's mission to preserve archaeological sites, to contribute to the archaeological record of northern New Mexico, and to promote public awareness. Additionally, the project fulfills the goals and objectives that have been set forth by the Fieldwork Committee, which are to provide opportunities to TASS members to learn, enable citizen scientists to make contributions to research through archaeological fieldwork, and to provide assistance opportunities for qualified archaeological researchers. So as part of that learning process, TASS, along with Natalie from the BLM, organized a training session for some of the TASS volunteers that were going to be participating on the project, which we held at Fred Baca Park before the actual survey. And so the goal here really was to give the volunteers an opportunity to become familiar with the equipment that archaeologists typically use in the field, such as compasses and handheld GPS units. They also learned the methods for survey and what to do when you come across an artifact, and then how to document those artifacts and features on forms with all of the pertinent information. And so I know here, Natalie and I really had a good time working with everyone on this, and especially having the opportunity, to educate folks on what the majority of archaeological work entails, which isn't always going on digs, but that this kind of survey work is equally important in terms of contributing to. So this project was, it also provided the BLM with an opportunity to meet some of its targets, which not only includes working cooperatively with local archaeological societies, but also to make sure that a certain amount of proactive work gets done. And so when I say proactive work, I mean projects that aren't related to some of that compliance stuff. It's more like the fun stuff. It's archaeology for doing archaeology's sake. And so these kinds of partnerships also benefit land management agencies in that way, because it means that they can have a better understanding of the archaeological resources under their jurisdiction. And working with volunteers, often means that sites can get recorded without some of those time and budget constraints that are often imposed by compliance projects. So really, it's just a win-win for everyone. Okay, so now onto the actual fun stuff. I'm going to be showing you guys lots of pictures of artifacts and talking more about what we found. But the project took place over 2 days in late September, with the goal being to survey and flag artifacts on the first day, and then to record what we flagged on the second day. And so here you can kind of see the general area that was surveyed, which is outlined in pink. I think this ended up being about 40 acres. And I think it would be appropriate to refer to this area as Blair Flats in honor of Bob. So our method of survey here was to kind of start along that northern edge of the Cerro, using the gorge more or less as an eastern boundary, and then walking west for a ways, gradually working our way north. And we walked a little bit closer than the standard 15 meters, just to ensure better coverage. But we didn't actually end up surveying as much as we had hoped, because we were finding so many artifacts. So just within this small area here, we documented over 50 artifacts, and that didn't even include any of the debitage. So by far, the most common type of artifact, other than the flakes, are these early to mid stage bifaces, which are consistent, with the types of artifacts that you would expect to see at procurement areas. I don't know how many of you aren't familiar with the term biface. I know it's kind of like an esoteric term, but it's just kind of referring to a piece of stone that has been worked on both sides. So you have flakes removed from both sides. But anyway, so going back to these bifaces, often groups will come to these procurement areas like this, and then rather than walking away with some of those like large nodules, or chunks of stone like you saw earlier, they'll begin some preliminary manufacture at the source and will work the stone down until it's a nice thin biface that they can then easily transport back to camp to finish making the tool. So, but what we see with most of these bifaces is that they were discarded and left there because of some constraint in the raw material that was making it so they could no longer get it as thin as they needed it or get it into the shape that they needed to, for further reduction into a formal tool. So if you recall back to the beginning, when I showed you this picture of lava on the ground, which is basically a sea of flakes, the reason for all that reduction was these bifaces. And so what we see in those waste piles is a lot of large flakes, especially with cortex, and cortex being kind of like the outer rind of the rock, which in these ones on the left here is kind of that purple color. And so this contrasts with what you would expect to see at sites away from the source, such as campsites or residential areas, where they're going to be refining those tools. We'd start to see more, biface thinning flakes or smaller flakes with no cortex. But just to give you a better visual here too, so the artifacts that we are finding are in this stage of the reduction process. And so there's just something about, the raw material that isn't allowing the napper to go from stage 1 to stage 2. And in this diagram here, stage 2 or stage 3 is probably the point at which they would take the biface back to camp for further refinement. And so basically in terms of the bifaces that we are mostly seeing out there, this is how far we are from a finished point. And so as cool as these artifacts are, they are basically rejects. And, there was probably a lot of cussing going on out there over the years. We did, however, find some diagnostic artifacts, some projectile points. And this, of course, is what you really want to find, not only because it is really just so exciting to find projectile points, but because they provide some of the only temporal information that we have for some of these pre-ceramic lithic scatters. And so what we are looking at here left is a San Jose point, and these date to the Middle Archaic period. And the age range for that is roughly about 6,000 to 3,000 years ago. The two in the middle could be variations of the San Jose type, but to me, they're more reminiscent of some middle to late Archaic points from the plains. But those would date to around 3,500 to 2,800 years ago. And the last one on the right there resembles later Archaic style dart points. And that one likely dates to around 3,000 to 1,500 years ago. And so as you can see, all of these points are made from a dacite-like material. Whether it's dacite from Newman Dome or not, we'd have to get it analyzed using XRF. And so, all that talk about XRF was basically for you to understand that in terms of these diagnostics and other ones that we might find out there, it very well could be the case that they are coming from some other source, which I think would be really cool to find out using XRF, because this would kind of help give us a better understanding of the kinds of rounds these forager groups may have been going on to gear up. So speaking of gearing up and going on rounds, these artifacts here we had were made from exotic materials. And the reason they're exotic is because they're coming from greater distances. And so this one on the left is likely a post-archaic arrow point. And the consensus was that it was made from Alabates chert, which comes from a source in West Texas. So that's really far away. We also had some obsidian artifacts, which are likely from the Jemez Mountains. So closer, but still at least a couple of 100 kilometers to the southwest. And again, we could use XRF here to know for sure. And obviously, it would really be great to get some more eyes on the ground out there and find some more diagnostics so that we can start to get a better and more accurate picture of the temporal use of the site. Other stone tools included ground stone. And so this artifact on the left here is a metate fragment made from what appears to be some of the local vesicular basalt. And then the one on the right is a one-hand mono that's made from sandstone. And so these two artifacts in particular are really cool to find. They could date to the Archaic period, or they could be more recent. But what they suggest is that people were not just coming to the area to procure raw material for making stone tools like bifaces and arrowheads, but that they were also exploiting plant resources. And because these sorts of artifacts are heavy and would likely be a burden to carry around or to transport, they often suggest that forager groups could have set up camps or residential areas nearby. And so again, more eyes on the ground to find more artifacts like these, and ideally some features that are associated with these kind of artifacts, especially out there on Blair Flats. That would be just really amazing and could tell us so much more, about resource procurement and settlement on the plateau. So the area has also been used more recently. There is actually an historic homestead nearby, and the area has been historically used for wood cutting and grazing. So I'm sure that as we kind of start to look out there a little bit more, we'll start to find some more of these historic period artifacts. But here we have a bucket on the left that has been modified with holes in it and was probably used for gathering pine nuts. And perhaps this is the same resource being procured with the groundstone, which I, for one, think is really exciting to think about the continuity across time there in terms of resource procurement. This artifact on the right is a hole and cap solder dot can, and the age range for those is about the mid 1800s to early 1900s. We also had some really interesting rock features, one of which Bob located on his initial reconnaissance of the area, and the other one was found by Joel, one of the participants. And interestingly, both of these features contain 9 stones that are not dacite. And one of them is kind of is located near the head cut of a drainage that may provide access down to the gorge, which I believe is the area that we are calling the Shackley Gulch. So this is also the area where there's those large dacite boulders are being exposed. These kind of features are hard to date, especially since we know that the area has been used for millennia. It's also hard to know what their significance is. They could be anything from trail markers to or even burials. But it would be cool to kind of scour the area for more features like this and plot them to see what their distribution is, relate to one another, and some of the natural features on the landscape. So in the process, of finding all of these very cool artifacts, volunteers really had ample opportunity to kind of learn how to document and record archaeological resources according to scientific and agency standards. And so some of the participants were totally new to this kind of work and were unfamiliar with the words that archaeologists use and the kind of attributes that we look for and describe. And so they really appreciated learning everything that was involved. And I really do think this was one of the most, for me, one of the most rewarding parts of the project, which is kind of helping folks to understand all of this. So this project was not just great because we had a chance to look more closely at this important site and document so many artifacts. And of course, it was great to see the BLM and TAS working together collaboratively, which hasn't happened for a very long time. But we were also able to partner with other researchers, like Dr. Steve Shackley, who I talked about earlier. Steve is professor emeritus at UC Berkeley. He's an associate professor at UNM in Albuquerque, and he is the proprietor of the Geoarchaeological XRF lab in Albuquerque. And so Natalie invited Steve out to kind of just help educate everybody on the geologic history of the dome. And then while he was out there, he collected some more samples, and in particular in the area where I showed you those boulders, hence Shackley Gulch. So Steve is most well known for his work with obsidian, and he is in fact the one who has documented all of the obsidian sources throughout the Southwest. And so among many of his other publications is this book titled Obsidian, Archaeology in the North American Southwest. So basically what I'm getting at here is that Steve is a rock star, and having him out there was really awesome. What's also awesome is that Steve has a background in archaeology. And so he, for one, really recognizes the value of this material archaeologically and the importance of dacite provenance studies in terms of understanding social interaction and movement, because that is precisely what he has done with obsidian studies. And so, it sounds like he's eager to come out to continue to work on the site, but it would also be great to get some other geologists out there who are studying the Taos Plateau volcanic field. So most importantly, everyone had fun. And I think that this really was the true goal of the project. This picture here is of Natalie from the BLM and task member Tim. And so Tim found this outrageously huge biface. I think it's by far one of the biggest bifaces I have ever seen. And you know, when I was putting this presentation together and I added this photo, I started to chuckle because if you look at it, that biface is practically the size of Natalie's head. Natalie, not that you have a big head, but in terms of bifaces, this thing is really a honker. So I think that this photo really sums up how we all felt about the weekend, you know, just lots of thumbs up and smiles. Nonetheless, you know, there still is a lot of work to be done out there and fun to be had. It really has so much potential for research and education. And so we surveyed and documented only a small fraction of what is out there. And so I think that as far as TAS and BLM are concerned, you know, we really would like to see this project evolve into a long-term project, perhaps something that happens over a couple of weekends over the next several years. We would hopefully like to involve some students from UNM and Taos and include documenting the site as part of students' coursework. And as I mentioned, you know, it would be really great to involve some more researchers like Steve and perhaps some archaeologists from institutions like SMU or UNM. I think as far as research potential, just a couple of ideas would be, you know, as I mentioned, to use XRF to analyze some of those diagnostic artifacts, to see if they are made from Newman Dome Day site or are coming from somewhere else. It would also be great to put in some testing units to see, you know, to get a better understanding of the geomorphology, to see if and where there is potential for buried deposits. And as Phil mentioned at the beginning, we are on the ancestral lands of several tribes. And so I, for one, would really like to involve the Pueblo and, you know, other tribes who might view this area as culturally important. I just think that it would be really great to get some Indigenous perspectives on the significance, if any, of this site. And then, you know, as we move forward, of course, I just want to say that, like, I really would welcome any ideas that you guys might have, and I would really love to see some more participation out there. And lastly, I think that this project, you know, and projects like this are important for land management agencies. So the more that we can record and document and research archaeological sites, the better agencies can make informed management decisions on how to balance resource protection with public use. And so out there, for example, at Newman Dome, there is some evidence for some recent wood cutting and grazing, and there are roads that traverse all over the site. And so I do think that it would be in the BLM's interest to better understand the potential of this site so that they can work towards protecting it. Okay, so just to sum up, I just want to emphasize why this kind of work is important. For one, you know, I think that it makes archaeology available to the public. It gives the public a chance to learn about the diversity of cultural resources in an area, and it provides non-professionals with an opportunity to participate in archaeological research and, you know, learn some of the methods and procedures for documenting cultural resources. And it also helps land management agencies, you know, fulfill their heritage program objectives. So, you know, ultimately, I just really hope that we can get some more folks involved and continue this partnership and document, learn more about this important cultural site. Okay, so the end. Thank you everyone for listening. I do want to give a special thanks to these folks who I think really helped to make this project a huge success. So we got Bob and Sally Blair, Mark Henderson, Natalie Sanford, Tim Vreck, Joel Clark, and Steve Shackley. So just want to open this time up, I guess, for anyone who has questions or comments. You know, if there's anyone out there who participated on the project who would like to add anything, that would be great. But thank you guys.
Yeah, you can, if you want to. Thanks a lot, Cassie. That was really good. Excellent. You guys did really excellent work there, and pretty much short period of time. And we had good weather. You guys had good weather, so that's great.
Great.
Yeah, so if you stop your share, I can get to the gallery. Yeah, what a crowd. Thanks everybody for coming.
Yeah, thank you.
Yeah, if anyone has any questions, we have a few minutes. You can put it in the chat or you can unmute yourself and ask the question if you want to.
Hi, this is Bob. Hi, Cassie. I just wanted to thank you for an excellent presentation. I just learned a whole lot. I've been out there a couple times since, and as soon as the snow melts and the sun is high enough in the sky, I'll be out there poking around again and trying to pinpoint areas within that site that are worth looking at.
Well, that's great. In which direction to go next?
Yeah, exactly. Thanks again.
Thank you so much, Bob and Sally, for everything that you guys did. And Bob, thank you so much for all the photos that you sent me. For the
Well, hopefully they were all worthwhile. And as I'm out there, I'm going to continue to photograph and GPS stuff as I see it.
Great, thank you.
Yeah, you can contact us. We're planning to continue this project in one form or another, and to continue the relationship on this survey and other surveys. So we want to get something going. So every year we have a project. You will see in the TAS website requests for volunteers. So normally it's kind of a maximum group of about 10, just to make it manageable. So if you like the idea of being out there recording out on the mesa, then let us know, and we'll set up a weekend. And if we get 20 people, we'll set up 2 weekends or something like that. So it'll be a smaller, manageable group for the supervisors. So everybody gets a chance to do every activity. As Cassie mentioned, that's the general idea. So yeah, you can either contact me if you want to volunteer at taoscuba@hotmail.com, or that's probably the easiest way. You need to be a TAS member if you're not, to participate because of liability reasons. So you could do that, but it'll probably be in September again. That seems to be the best weather. It can be hot in August, so we'll shoot for a weekend of September and have some activity by then. So when Corona's all over with, right? So, but anyway, is there any other questions from anybody?
This is Gretchen from South Carolina. That Alberte's church is from outside near Amarillo.
Yes,
up in the Panhandle, and it's found all the way into Illinois and eastern part up past the Mississippi.
Wow, yeah. It's just
so that was traded all over because it was a very fine quality and it was very tough.
Correct.
Best, yeah.
There's a lot of it down by Carlsbad in the mountains there around Rio Dosa, in those sites closer to Texas, of course. Alabates, she's talking about.
Yeah. It's also referred to as bacon chert. That wasn't a great example that I showed. It was kind of blurry, but some samples from it have these like really crazy, they're like pink and white bands, and they do look like a slab of, side pork or something. So we call it bacon chert.
Yeah, so we will be, we got a recording out of this. So if you missed the people that came in late, if you missed part of this talk, it should be on YouTube by tomorrow, if that's okay with Cassie. You'll be going coast to coast international. So you can look for Newman Dome and it should pull up as a subject in YouTube. Okay, well, thanks everybody for joining us. Any other questions at all?
Hey everyone, this is Natalie. I just want to say this awesome presentation, Cassie. It was so cool to see this come together, and I'm looking forward to chances to volunteer.
Hey, thank you, Natalie, for coming.
Yeah, and I think we'll be able to get those samples together and we'll send them into XRF as soon as you want to. We can, that's what TAS should be doing with our field work committee money. So
Yeah, one thing I did want to do, I guess before that, is something that Natalie and I talked about before too, is just kind of consulting with the tribes to let them know what we were out there doing, and if they wanted to input in any way, I think would be the
good
professional
idea.
doing that. So I mean, that's something that I would like to maybe focus on, before we get out there again.
Right. But yeah, you probably have 6 or 7 samples there. You might want to XRF.
Yeah, definitely.
Yeah, so we'll do that. No problem. Done. Okay, well, thanks for joining everyone. And just a note while everybody's here, the next meeting is going to be February 21st on a Monday. So it's kind of an off day and an off week for us, but we had some conflicts. So we have a speaker that will be Franklin. So we'll be talking about ceramics from around, I think Isleta maybe, and the Albuquerque area. So we will see you then. Put that on it is in the calendar on the website, but it'll be February 21st, Monday, at the same time, 5:30. So keep an eye out in your emails for that information.
Great. Well, thank you again so much, everyone, for coming.
Thanks, everybody. Take care. Be safe.
Good evening. Happy New Year.